Hello everyone and welcome to a new thing, a new video that I'm doing. This time it's about someone called Aloha from Florida, and apparently it's 3 things about the moon that are not possible at the, what they, I assume, call it, the heliocentric model. We will have a look at that.
Good morning. Aloha
Hello.
from Florida.
Good evening, well, not yet, good late afternoon I guess, from Austria.
Let's talk about the moon very briefly. 3 things. I've mentioned these 3 things.
I love it when people talk and drive. That's like, for a video that's totally safe, but yeah, okay.
Separately several times. I don't think I've put them all in one little video, so let's do it real quick.
Yeah,
The first
okay.
one is the inverse square law of light and the light that is coming from the moon. The inverse square law of light says that light diminishes by half every time you double the distance.
No, it diminishes by quarter every time you double the distance. It goes with 1 over the distance squared.
So if you take the light that is hitting the Earth during a full moon and you double that brightness every half distance back to the moon,
You would need to quadruple that distance, like square it for that case. If you double the distance, you need to quadruple it, but in general you could say you square it.
The moon's alleged distance of 238,000 miles, the moon would be brighter than the sun in the sky.
That is not true. The moon would be about a tenth, like at the moon's surface it would be about a tenth of, there or thereabouts, a tenth of what we would get on Earth, like from a the maximum one that on Earth we get is about 1,300 watts per square meter, and on the moon's surface it would be at about 150 or something. I will calculate that.
So the globe is completely debunked. The entire heliocentric hypothesis.
I love how you just say that without providing any sort of calculation, like you just say it as a statement of fact without providing any evidence. I'm leaning out of the window here and saying that you haven't even done this calculation once.
Is debunked with the inverse square law of light. Another thing.
Also, the inverse square law is something that you learn in like late high school, in my case, or like early university at the very latest. Don't you think that we would have figured it out by now? Like, how come that no physics or astronomy or meteorology or, I don't know, heck, like even electrical engineering students haven't figured that out? Is it because we're all stupid, or because you're so bright, or what's the deal here? Why shouldn't we have figured that out by now?
The thing about the moon is the moon phases, or are the moon phases. They do not change every 6 months.
They change every 28 days, if you want to be specific.
If the Earth were a little ball rotating and revolving around a huge sun, the moon phases would reverse about every 6 months, because the light coming from the sun hitting the moon and the Earth would be coming from the opposite direction. The moon.
But okay. So the confusion here is about the duration of the moon's phases, like the moon cycle, if you will. They last about 28 days. Not exactly. I think it's 27 point something. So that's kind of enough. Like you go through a cycle 27.3, I think, days, and that's how the moon changes phase. Actually, the moon's phases would be different if we wouldn't orbit a star. That it's like with the sidereal day. That's not the actual day. It's the same reasoning like that with the moon. So that's not a real problem, really. It's maybe before you make these claims, could you have an actual look at what we say and make an effort to understand it? That would be highly appreciated, I think.
Phases are always exactly the same, like they were designed to be. We live in an intelligently designed, enclosed, electrical, topographical, stationary system.
A lot of claims there with very little evidence.
Commonly called flat Earth. So the moon phases don't reverse. They're always exactly the same, as the moon seems to be chasing the sun across the...
But the moon always rotates in the same direction. I get that what you mean, that they should be different, because the moon is like at the exact opposite position of the sun roughly 6 months later, right? But to us, this will seem, how do I put it? The moon changes the phases every 28 days as it is. So the direction of where the light comes from over the distance, like over the time of half a year, this will only be such a gradual change. I don't know exactly what you're on about.
The sky, the sun moves a little faster than the moon, and it laps the moon once a month. And the third thing is the new moon. Where is the moon every 28 days? It can't be seen. It can't be detected with any optical or scientific equipment at all. So the new moon, where is it? Where is the moon every 28 days? It's simply not there.
It's because the moon is so close to the sun in the position in the sky when there's a new moon that, I mean, it is there, but it's like so close to the sun that you need a specific filter or possibly even a mask to mask out the sun to detect the moon.
Even if you are a globe believer, you have something called earth shine that would,
yes, Earthshine exists,
allow the sun to hit.
But Earthshine exists in, well, I mean, it obviously exists in a day as well, but you wouldn't see its effect unless it's night, and because the moon's so close to the sun, you would, for practical purposes, never see a new moon full stop.
The Earth, reflect a bright light off the Earth back into space, and show us the moon during a new moon. But no, in reality, our observable reality debunks the globe. Our observable reality is that the moon is just simply gone every 28 days. It cannot be seen or
it disappears. It was stolen by a dragon or something.
Detected at all. So, the inverse square law of light debunks the globe. The seasons, or not seasons, the phases, the moon phases debunks the globe. And this last one of the new moon completely debunks the globe, because the heliocentric hypothesis says the moon is a rock, a dusty rock in space. Of course it's not. If it were, we would still be able to see it every 28 days. But in 28 days, you don't see it at all. So those three little short things about the moon debunks the entire lie of the heliocentric hypothesis. That's it for today. Have a good one. God bless. Oh, 10-10-23.
So, no clue what that one was all about. Obviously very wrong, and with no supporting evidence whatsoever. I also don't think that there is anything, no, there is nothing linked whatsoever. Big surprise.
The Mechanical Realm. Go to themechanicalrealm.com, get more information. We will be releasing information, historical and scientific, true information about the Earth being flat and stationary, with a working model that is over 2,000 years old.
Oh, of course you will. I will maybe have a look at that in the future. Now let's have a look at all of the claims. So, the often cited by flat earthers but very, very rarely actually understood inverse square law. It applies to a point distance that radiates radiation out in the same way, in the same intensity in all directions. And so you can say, you can make geometrical considerations that if you double the distance, the surface of the sphere, where the radiation sphere, if you will have quadrupled, because it goes with the radius squared. And so what you can say is you have to double the distance and you have a quarter of the radiation that was there at whatever other distance it is. So the intensity I is proportional to 1 over r squared, r being the distance. And there are a couple of problems with that. When applying it to the moon, first and foremost, the moon isn't the point. Flat earthers kind of seem to ignore it, and don't get me wrong, it is fine as a way of approximation, right? But it isn't something that you should do like in general, I'd say. So the moon isn't the point. Actually, if you would like to do that properly, you would need to assign a point, like multiple points, we're talking thousands probably, to the surface of the moon. And because the moon is extended, it's not a point, it's an extended target. It has surface, right? And as you get closer, you would need to calculate the radiation that comes to you from each of these points individually. And as you get closer to the moon, because the moon's a ball, you will see fewer and fewer of these, right? So there is a point where actually it will become less bright to you, because you are being exposed to less of the reflected light, because you're so close to the mirror, if you want to call it a mirror-ish, right, that you're getting less and less radiation. Technically, if you would like to do it analytically or properly, you would need to integrate over all of the surface, which is oh Jesus, no. So the second problem, that's by far the bigger one. Like the first problem, that's more like a caveat. That's more like something that's interesting to know. But for an approximation, you can use the inverse square law. It's fine, right? So where is the calculation? You just say that. So I thought I'd do the calculation. For that, we need a couple of things. First of all, during a full moon, you have, and that's a bright full moon, you have about 0.003 of a watt per square meter. So 3 milliwatts per square meter of radiance. The moon's distance in kilometers is rounded up because I'm being generous. And if the sun's overhead at the equator, you get about 1,360 watts per square meter. Ish, there or thereabouts, right? That's just for an approximation, that's fine. So as we know from up here that the intensity of the light is proportional to 1 over the distance squared. We can do that right here. So we go the intensity at the surface, which is here, that's the surface, by the way. It doesn't say 0, right? Because you can't, first of all, you can't divide by 0, and secondly, due to the first reason we have had up here, you can't go to 0. Like 0 would be the center of the moon. So we are not going to 0. We are going from the surface. So the 0 distance, so to say, is the surface of the moon, which is just the moon has a radius of 1,700 about kilometers. So, and I'm doing this obviously in meters. So the distance here is 1.7 times 10 to the 6 and squared, obviously, and the distance from Earth to the moon is about 400,000 kilometers. It's a bit less, it's 384,000, but that's not important. So the formula you would get is the intensity at the moon's surface is this, where the intensity at a distance, so at our place, is this value right here. And if you plug in all of the numbers, I hope I didn't do any calculation mistakes, but I think I should be fine. If you plug in all of these numbers, you end up with about, well, 166 watts per square meters. This is heavily rounded and in favor of the flat Earth. The value that you find in literature is usually about 143, I believe. And that's just the radiation you'd get on Earth on a cloudy day. So how exactly is it brighter than the sun? If you're a flat earther and you're watching this, feel free to tell me what I did wrong. Also, if you're a glober and you find a mistake, feel free to tell me what I did wrong. So the first claim obviously is bollocks. And regarding the second point, you can see right here, this is a website. I will link it, of course, in the description. They actually explain that as the Earth moves onto its orbit, you can see that the moon actually goes through a bit more every time it goes around than it actually should, right? If you're stationary, you can see that here. It's also on Wikipedia. I will leave links to all of that in the description so you can read it for yourself. But at the end of the day, it does exactly what we would expect it to do on a planet that's revolving around a star. So yeah, maybe check your claims before you make them. And talking about the third point, today, as I'm recording this, which is the 14th of October, and I changed my position a bit so that I'm not getting knocked. So, but apart from that, you can see actually pretty nicely, this is of course a simulation, that the moon is right here. You can, I guess, get it. It's in German, by the way, and that's the sun. So of course, why don't we see the new moon? Well, because it's so close to the ruddy sun, then, isn't it? Also because it's cloudy today, but that's of course a completely different topic. And if we look at the sun and the moon throughout the day, and the sun will set, or has already set here in real life, but when the sun will set today, the moon will be extremely close. Maybe you can get a glimpse there, but I don't think you will. This is about the thing that you would see, and obviously you can't see the moon at night because, well, it settles pretty much with the sun. That's why you will never be properly able to see a new moon. You might, if you're very lucky and if you have a good view and the atmospheric conditions are ideal, very briefly before sun up, you might be able to see a tad bit of a new moon, but you would need to be very, very lucky for that to happen. And I believe with that we are all done and dusted. If you enjoyed this video, please do consider leaving a like. If you enjoyed it a lot, maybe I can consider you to consider subscribing. Yeah, other than that, I will see you in the next video, and until then, have a nice time. Goodbye!